Hi, so in this clip we're going to have a look at how to perform a manually calculated t-test in Excel for a paired set or dependent set of data. So the situation is that we're looking at the growth rate in millimeters, which was recorded for a set of plants to check if the addition of fertilizer changed the growth pattern. The measurement data for the weeks before and after the fertilizer was administered are shown in the two columns. And we can see our set of data is in pairs before and after. So our first question is, what are the two hypotheses for this situation? So our two hypotheses are shown here. The null hypothesis is that HO mu post-fertilizer is equal to mu pre-fertilizer. In other words, the population mean after the fertilizer is the same as the population mean before the fertilizer. And the alternative hypothesis is that X bar post-fertilizer is not equal to X bar pre-fertilizer. In other words, the mean of the sample after the fertilizer has been administered is not the same as the mean before it was administered. The next question we'd ask is, what are the formula that apply to this situation? So the two formula we need for a paired t-test are given here. One to calculate the t-statistic and the other to calculate the degrees of freedom. So I'll just add in a few headers for where we need to do some calculations. The first value we want to calculate is a number in each sample, and we can use the function count for that, equal to OUNT and open bracket. Select the area of the sample, close the bracket, and that gives us 22, and we can pull that value across to give us the same value for the after set of data. Next we want to look at the differences between each before and after. So we'll say equal to first minus the second, and that gives us our first difference value, and we can pull that down using the autofill function in Excel to calculate for the rest of the data. Next we want to look at d squared, and that's equal to d and then raised to the power of 2, which is the up arrow over the 6 key, and that gives us the first d squared value. So we can similarly autofill that down here. Now our summation values are given by using the sum function. S equals SUM, open bracket, select the area, close the bracket, and again we can pull that value over to summate the d squared column. So after this I'm going to just fill in a few of the columns, the next set of calculations that we need to do to move on to calculate the t-statistic. So the first set are here. So we want first of all sigma d, and that's equal to this value down here. We can press return, and then n we have already calculated. We can say equals this value here. Sigma d squared equals this value here, and then sigma d overall and then squared equals this value here to the power of 2. And we could then go on to look at the next set of calculations we need to perform. The first figure we need is n sigma d squared minus sigma d overall squared, and that's given by equal to this multiplied by this figure minus this figure, and that should give us that. And the next figure is given by that figure divided by n minus 1. So we go equal to this divided by open bracket n minus 1. And then next we get the square root of that figure that we've just calculated, so equals SQRT, open bracket, close bracket. So now we're in a position to calculate our overall t-statistic, and that's given by equal to this figure here divided by the figure we just calculated most recently. and that should give us a value of 1.636359. So we now can go on to look up our T critical once we've calculated our degrees of freedom. Our degree of freedom are given by the formula n minus 1, so we can say equal to, and n is down here, minus 1, and that's 21. And the next thing is to consider alpha. Alpha is equal to 0.05 is the standard value, and there's no reason really to move away from that, so we'll set at 0.05. And now we're in a position to go on to our t table to look up the value that's appropriate for those figures. So here we have our t table, and our alpha is 0.05, and it's a two-tailed test. So we locate our cursor over here to 0.05, so we're interested in that column. And then for our degrees of freedom equal to 21, we can locate down, and there is a value for 21 which is just here. So we can read across from there, and that value gives us 2.080. So we come back and fill that in and compare it to our t calculated, our t stat. So our t critical from the table is 2.08. So our t stat therefore is less than our 2.08. And if we look at our chart of the t table distribution, we can see that we haven't got as far as the rejection zone, so we're not in a position to reject a null hypothesis. T stat is less than t critical. There's no basis to reject a null hypothesis. There's no basis to support the alternative hypothesis that the fertilizer has had an effect. The null hypothesis that mu post-fertilizer is equal to mu pre-fertilizer therefore stands. We can then, if we want to, go on and check our results in using the Excel data analysis toolpack. So to perform the t-test using the data analysis toolpack, we locate up here and we click on data and then data analysis, and we choose the t-test, which is down here, and it's a 2 sample for means. This one, say OK, and then we need to select our first set of data, and that's here, so I select that, and then the second set of data, this set here. And because I have also included the 2 headers, I need to signal that to Excel by clicking on labels. The output we will put into the spreadsheet itself, so we touch on output range here, and we select, and we'll pick a point to put it at. We'll put it here, and we can then say OK, and we can see now that Excel has generated a set of data. And we can see the value of the statistics that it has generated are very similar to the ones that we've manually calculated ourselves. So we've concluded our task at this point.